Welcome to our CapStone project presentation. We have developed one serverless application which is having two parts, backend and frontend. Backend is developed in Node.js APIs, basically backend APIs, and frontend and application developed in Angular, which we have also used Visual Studio to push our code using Git to AWS, and then in AWS we have used CI/CD pipeline, code pipeline service, which where we create a code build, a build project, and pushing CloudFormation scripts stack, which create the stack and provision the rest of the services like DynamoDB static, one bucket and one a few buckets which is required for backend logging, and CloudWatch logs and all have been created for this. And we have tested this application through Postman as well as through browsers, and like Internet Explorer is not working for this application, and but Google Chrome and Microsoft Edge is working. So in this application, as I told, that it's basically a task or add notes for your day-to-day life. You can add note, update, delete, and get the notes. If so, since this application is basically a new, there is no notes right now. We have added few notes. We have to add few notes. So this we will do step by step. We'll adding first notes there. So once we have to provision, we'll first create the repository and then push our backend code and then front-end code. So right now, as I'm adding some nodes, I'll also explain what are all things. And then after that, we'll also create one static bucket and creating a website, and then we will deploy our application to from cloud. Everything will be from the cloud. So after this front presentation of the application, regarding application, we'll start immediately for rest of the part of the application. So we have added some nodes. We'll also test here some. We'll also show that this application limitation, it will not work in Internet Explorer, and it since this application is basically a developed in AngularJS, then it obviously will work in the rest of the nodes. So the rest of the like mobile and on or other browsers. So now we have tested this application in Google Chrome. We have added some nodes, and also we have closed the current browser, and we are now trying in Internet Explorer. In Google Chrome also we have tried to close the existing tab, and we have tried it. Rest of the means the same endpoint we have tried in another tab. It is working fine. So as I told, it will not work in the Internet Explorer, but since it is responsive design and all, we have done some changes. Means it was there already in the code. So it worked fine in the handling for the Microsoft Edge. So it's working fine with Edge. Whatever nodes we have added there, it is coming here. So we'll also create a 1-2 nodes here and see that in the Internet Explorer whether it is working fine or not. Yep, and Internet Explorer also we can see that yes, whatever node we have added, it is updated coming here as well. So we can delete node here, and we can also edit node to see that functionality is not working. We have used the DynamoDB as a backend, so we'll also look whenever it is required in the DynamoDB side. So now go back to our application. The design, it is basically we have done in steps. In step 1 we have only done the, from the local we have only generated provision the DynamoDB, so that it's fine in step 1. Then step 2 we have in the backend, and then step 2 we have provisioned our lambda functions only in local, tested through local. Since we need only DynamoDB in a cloud, then only we have provisioned DynamoDB. So this is our step 2 what we are talking. And we have deployed through serverless deploy. We have whatever we have done in step 2 we have not do it here, only that or endpoints we have lambda functions we have tested from here. In the step 3 we have push our nodes, all the basically API functions in cloud and tested. In step 4 we have added up our CI/CD pipeline. That's what we have to start from the very next step. So in the next step we'll do the cloud commit, we'll test everything. This is the whatever we are doing here, creating a cloud formation, CDs, generating a CI/CD pipeline, and using this cloud commit, cloud deploy, cloud formation. Our lambda functions will be provisioned, API function will generate, test, we'll do the testing through Postman and check the data it is coming fine or not. Everything we will do it in our from there. So next step, as I told, we'll have to create a one repository first. We'll create a repository in cloud commit for backend code. So it is created. Then we check this endpoint to push our code from our local to cloud in this repository. So we will use this as endpoint as origin of cloud commit. So this is our code we have, and in this code we have already tested locally. We have all nodes here. We just init the everything is fine and tested. Now this we have to do the git init to push our code in cloud. And then we check that everything is none of the file has been added there, and we have check out the one branch, create one branch and check out. Now we have added all files into our branch. Now nothing to add, we already added every files. Now we have to commit all files whatever we have added. Once as we can say, yep. So first code commit is done. Now we have to make this origin of cloud commit as make it in adding up in the origin, so that we can push our code from local to that AWS code commit bucket, code commit, yep, repository. Correct. So this is we have done. We have pushed our code. Once that code is pushed, we can see in the cloud code commit our code should be there. Yep, our code is here now. So our code is fine. Now we have to go and deploy our code and check. Basically we have to create the pipeline here. Now we'll create the pipeline. In that pipeline we will deploy our code and provision all the services, like what we have done, lambda function, DynamoDB and other and S3 buckets will be there, IAM functions will be required. So we are giving this code pipeline name as SLS backend pipeline. We'll use the existing role, say from the past exercises we have used. The same we will use here instead of creating a new one. Yep. So as it is, then nothing we are changing here apart from this. No need to change anything. We'll just go. Now we have to point our, in this pipeline we have to, whatever code we have and committed in the cloud commit, we just push. We'll take the bucket, that repository, and then branch. In the code build, we'll have to, everything is in North Virginia, so we have to choose the North Virginia everywhere. It's basically US East 1. This is the, and then we have to create a code build project. It's basically a build will do. We will not do the code deployment because since we only have to push code to cloud, basically Lambda, AWS Lambda will do everything. So now we have given the project name as SLS Nodes Backend project. We are using Linux standard and standard 2. Everything should be fine, no need to change anything. We are using existing role from the past exercises we have added, so we'll use that because we need some access rights here. We have used this role. We also have to set up one environment variable here as prod. It is required in our code. We have to use build spec YAML file for deployment purpose, which will trigger the deployment. We also have to create the loggers file, and once it is done, create, we can skip this step, and now we have to verify everything. Once it is, we find that everything is fine, we can push, or we can create your pipeline, which basically trigger our deployment process. We can see the right hand side, the deployment has been initiated, pipeline has been initiated, and now we have our first step is done, and then code commit one. Then as soon as it is it find, the system will find there is a point where we have the code commit, anything done, then it will automatically start the our build process. So build is happening now. Let's wait for some time. We will have some files here, and means we'll have the loggers here for the deployment steps. We will monitor some steps for, since we are doing it for presentation purpose as well, and we'll also have to go to monitor it. We'll monitor everything here. This application requires some coding efforts, which is we have not gone through. We have taken application from some as is. We have not put our expertise on the application code side. Yes, but we have proved our expertise in the cloud side, provisioning the service and all. So let's see if there is a cloud formation is there or not. No, it is not there. But the logger has been started. We can see that the process has been initiated. Let's wait for some time, then we will have our build process will be completed. And it will provision our AWS Lambda functions, all 5 functions: API gateway, DynamoDB, table, CloudWatch logs group, S3 buckets, and CloudFormation. The stack will be complete. So once the stack will initiate, everything will be start provisioning. The system will start provisioning everything. So first, our point is that the system should start provisioning the cloud formation. So just wait for some time. It's doing it. System is that is in progress. It installed first npm as a node.js environment. It's creating environment, provisioning the environment system, and we don't need to care about any functions. So we have to provision an EC2 or any other system in this case. So we can see that the stack has been started. So since it is very easy, there's no need for me to take care of any backend application server or web application server like that. So it is also that it's very easy that to CloudFormation is basically a infrastructure as a service, code as a service, code infrastructure as a code. Basically takes CloudFormation and it is doing its work and provisioning the environment for us. So we can see that now CloudFormation is it's kicked in. Now we can see that our bucket has been created, our DynamoDB table has been created, and also we can see that our lambda functions is also there right now. Let's see if there is a API gateway is there or not right now. It takes some time. Might be we have to close it and create it again. Let's see first. Try to refresh sometimes. So yeah, our endpoints are also generated successfully. Our build is completed. CloudFormation is completed. S3 bucket has been generated. Lambda function has been done. Everything is done. We can see what all the things has been completed successfully. Yep. So this is part has been done. Now after this we have to test this backend application through Postman. That we have to do. We'll take the endpoint from our API gateway. From the we go to we'll just add that one resource. We'll take that and no endpoints. We see that there is nothing here in that, and all the tables has been created successfully. Yep. So that environment has been successfully created. Now we need endpoints to test the same. Yep. So we go to API gateway, stages, post, because post is basically create a post. We take this endpoint. We have done rest of the things from the previous exercise. We paste our endpoint here, and we will content type as JSON, app user ID, app username, and body part we will give the what value we want to insert in our DynamoDB through this for this application. Everything is fine, then we will send or trigger this data to cloud. So once it is successful, then everything is fine. Yes, our application as the deployment has been done successfully for the backend. Everything is fine. Now we can also go and verify in the DynamoDB same, and go to DynamoDB, just verify, we'll go to items and then just refresh it. Yes, we have our data ready here. It has the data, whatever we have created, timestamp, user IDs, note ID, expiry, everything is there. And after this we will go and start the front-end application. We have to create one static bucket which will be used in our front-end application, and we will also create in this static bucket one static website We will also provision our do the code build so that the code will come here, deployment code will come here, whatever we have developed in the Angular. We need this bucket public access. Since we have done this application, we will use as front-end application. Otherwise route 53 is the option, but route 53 we need to pay for that. We don't want to do that right now since it's a part of CapStone project. So our bucket is now ready, but we have to give the create one static website. Also, we have to generate one bucket policy for this bucket. We need this ARN for bucket policy. Copy that. We need this bucket as public access just to confirm it. We have to create a bucket policy. We'll create a bucket policy generator. Click on policy generator. Principal, we have to give asterisk for all wildcard selection. We also have to choose okay, we have to choose select type of policy is basically S3 instead of SQS, which was doing wrong here, and we have to choose here in the actions as get objects. That get object is done, and we have to paste the copied ARN slash asterisk for wildcard and it need to add this in statement, and we have to generate the policy. This policy will copy paste in our bucket policy of S3 and save it. Once we will save this bucket will be system will say that this bucket is public access. It's now accessible. This endpoints what we have given in for this bucket will be ready for public access. After that we'll create a code pipeline. Again we will push our application from cloud to here. We need an endpoint and we need a bucket name for the front end code. We are taking it, and so that in the front end code we'll have to change it. After that we have to deploy and everything we have to do. So we'll build it and we'll deploy this application. So this endpoint is required in our code and S3 bucket name. Just verify once more time that everything is fine. This ARN is, we have this bucket name copied. Go to our front end code. We have to change few places. Rest code we don't want to change anything because it is a front end code. It works as is. We have the related to our application these files, note related files are for our front end code. We have to change this our bucket name here in build.html because it copy or our build code will be deployed in S3 bucket. So it will move our code. And web spec, we have to change our endpoint here from here to here. So we will, for sake of no issues, we will change it in both dev and product. Prod is not required, but since there'll be no issues should be required, then we'll do that. And after that we'll do the build, and after build we will just move our code to cloud. Since we have already tested, so there is no need for us to test it locally again. So once everything is fine, we have tested our code, we build the code, and after build the code, we have to push our code into cloud commit. We have created another repository. We have to create another repository for the front end code. We'll give that as a SLS nodes app, create it. Similarly, we need the endpoint so that we can push our code to this origin. Copy paste in our old nodes. Since it is a developer node, so no need for anyone to understand much about this. These are steps. It's just having the steps scattered way. So now we'll again do the same steps to push our code from local to git init to cloud. We have to push our code from local to cloud, git init, then check out the dev branch, switch to dev branch again, then we check the git status, git add and git status again. After git add and code commit will be there, and finally we will push our code from local to code commit origin. So this is, we have already tested. Now we have to do the commit. Git commit -am, and then need to give the commands as first. Front end code commit, code has been deployed. Move, we have to push a code from, we have to add the cloud commit endpoint as origin, and then this will push our code from local to cloud code commit. So this is done, guys. Once everything is fine, then we have to create another pipeline for front-end code. Just verify first a code should be there now. If it is not there, just wait for a moment and then refresh again. And once it will be there, we have to create the code pipeline similar way, and once that is there, we will have to put our code, we have to check that our, since there is no need for us to do anything extra in the cloud, just you have to check the endpoint our application is working fine or not. So let's see. I hope the code is working. Yep, we can see. Wait. Yep, I hope this time the code is there. Yes, our code is here now. No issues with that. Everything is moved correctly. Now we'll create the code pipeline. In the code pipeline, again, we'll give the name as SLS nodes backend. Not app backend, it's app. So it's basically, since it's a front-end application, Role, we will choose it from the old again from the old ARNs what we have created. Roles, will not create a new one. Code commit we will use as a stage, source as a source stage we will use code commit. Repository we will use the front end code, and branch as well. We'll choose the branch. Now we have to do the code build. Similar way we will create the code build thing, but here it is not much. We'll use the same thing whatever we have choose there for the backend code, except the environment variables also required, no need to set here. We'll choose the Linux. Runtime we will choose it as this. This role also will have used the earlier one which we have used for the backend code. Build.xml, build.yaml, specs.yaml for file for our deployment file. Create. We have to choose the runtime. It is basically standard 2, and then it's fine. Yeah, it should be fine now. And then create. Once it created, it close the window. That pipe project name it's coming here. Next, and then escape because we don't need the deployment. Verify everything and then create it. Now since we are after commit, everything saved, then our build will start automatically. Build process, just wait for some times, then it will deploy our code. After that we will just test our endpoint of the S3. So once that will be fine, then we can test. We will also verify that our code has been moved or not correctly. Yep, our build is started. Just wait. Take some times. So we can see that it is also completed. Front end also completed successfully. Everything is done. Now we have to verify everything in the cloud as well. We'll go and check in the log groups. We have created a separate log group for front end and back end. Yep, we have the separate groups for back end and front end. Also for lambda functions is separate. We can also see that logs here for app side. Everything should be fine. Now we have seen, we can check our bucket. Bucket is also created. Refresh it. Our code is here. We'll go to property. We go to our bucket. Go to property of the bucket. Then we'll take the endpoint and click on it. Once you click, it should be take us to the our deployment code. We'll see that whether it is working fine or not. If not, then we have to see why it is not working fine. So let's see. So it works fine, not an issue. Now we can test our application. So we can create one node, delete node, all these things we can test once. We have added one node. This is the second node we are adding up here. It's working fine. We'll add it as well. Here's some relevant thing. Update nodes, fine. Let's see. In delete, not need. We'll create another one. Edit note, we'll say, and then note, we'll say edit note. save it, add note, delete note, or basically task 1. Easy for us to delete this task if it is will give this kind of irrelevant task notes. Okay, save it. Okay, server less project, yeah, good for us. Fine, we'll just delete one. Dr. Strange we are deleting. We'll see in the DynamoDB, yep, our application is also fine. Everything is going as expected. We can delete everything from cloud by saying that in our code commit build.xml YAML file, we'll just have to change our deployment to deploy to remove. That's it guys, I think everything is fine. Just showing you how we can delete if you want. Yep, so SLS deploy, we can remove it, it's fine. We remove it and then it will automatically trigger our another build as soon as then it will delete. Thanks everyone, and then thanks for watching. We'll clear up all the questions in our Viva. Thanks everyone.